Hello everybody, welcome back. In this video we're going to be talking about situations relating to Unit 2, Section 3 of AP Calculus, estimating derivatives of a function at a point. And what we're actually going to do in this particular section is we're going to look at three different scenarios and methods that we're going to use to estimate derivatives of a function at a point when we're estimating the derivative from a table. And when we do that, our best approach is to use the average rate of change on an interval to estimate the derivative. We're going to estimate the derivative from a graph by estimating the slope of the tangent line at the appropriate point. This is probably the hardest of the three to do, at least accurately. There's a lot of room for differences, slight differences in people's answers. And then estimating the derivative from an equation, which we're going to use the numerical derivative on your graphing calculator. There are a handful of things you're allowed to do on your calculator on your AP exam without showing any work. Finding the derivative at a point on your graphing calculator when given an equation is one of those things. So that's going to be a very important piece of the puzzle for when your AP exam rolls around. All right, so let's start with example 1, which is adapted from free response question number 1 from the 2016 AP Calculus AB exam. Water is removed from a tank at a rate modeled by R of t liters per hour, where R is a continuous decreasing function on the interval from 0 to 8. Selected values of R of t are shown in the table below. And we're going to estimate R prime of t and show the work that leads to our answer, and indicate units of measure. Okay, so we have a table with t and r of t, which means that r prime is the instantaneous rate of change of what we see in our table. Whenever we're asked to find the instantaneous rate of change of what we see in our table, what we're going to do is we're going to identify the interval where we're finding this derivative, or estimating it. In this case, we're looking for the estimate at 2. So we're going to find the interval that contains a t value of 2, and that is the interval from 1 to 3. And generally, my general advice is you want to find the smallest interval that contains the point that you're trying to estimate the value of. It gets a little strange if you're trying to estimate the value at a point that actually appears on the table. But if it doesn't, this is actually a pretty straightforward. Find that smallest time interval that contains 2 and use the average rate of change on that interval to estimate the value of r prime. So we're going to say r prime of t here is approximately equal to, and I'm just going to go ahead and calculate the average rate of change on that interval. Gives me negative 240 over 2, negative 120. We're supposed to indicate units of measure. Our numerator is liters per hour, and our denominator is measured in hours, so this is going to be measured in liters per hour per hour. There you go. That's how we can estimate the derivative from a table. All right, estimate r prime of 5, show the work that leads to your answer, indicate units of measure. Okay, so again, for 5 is on the interval from 3 to 6. So we're going to estimate r prime of 5 using those values from the table. And so I'm going to go ahead and say r prime of 5 is approximately equal to 740 minus 950 over 6 minus 3 gives me negative 210 over 3, or negative 70 liters per hour per hour. Okay. Let's go ahead and turn the page, see what we have in store for us next. All right, now we're looking at graphing. And so here on our graph, we're supposed to estimate the value of p prime of 4. And my numbers are a little hard to read on this graph grid. But right here is where x is equal to 4. So what I'm looking for is I'm looking for the slope of the tangent line at this point. And so what I'm going to do is I'm going to go ahead and try to sketch the tangent line at that point and get the contour of the curve as best I can. I think I did okay. And once I've got that tangent line, what I want to look for is I want to look for places where, I've got a point on the curve that we can use to estimate, or a point, pardon me, on this line that we can use to estimate the function. I'm going to say right here, so I've got the point 2.5, comma 2 is one of the points on this tangent line. Oops, not 2.5, 2.2, just 2.5, 2. And then another point, well, why don't I use the point that appears to be my point of tangency? It looks like it's about the point 4, comma 7. And once I find 2 points like that on the graph, I'm going to go ahead and approximate p prime of 4 by using the average rate of change between those 2 points. And we divide through here, and we've got, looks like 3.3 repeating. There are no units given in my problem here, so I'm not going to put any units in my answer. And I'm going to say, p prime of 4 is approximately 3.3 repeating. Now, when we estimate from graphs like this, again, I'm just pulling points from the grid. There's a lot of room depending on which points you pick. Obviously there's some room for judgment as far as where the line, which, grid lines the line is traveling through, etc., etc. So there's room for some variance in this value. Not everybody is going to end up with the exact same value when we estimate from a graph, whereas we should with the other methods. All right, example 3, the graph below is a graph of the equation y equals f of x. Estimate the value of dy dx at x equals -2. So this is the same thing as f prime of -2. So we're going to say dy dx evaluated at x equals -2 is approximately, and now I find the point on the curve. Right there is a point. And then I try to estimate what the tangent line looks like. And hopefully I do a pretty decent job of this. Looks pretty close to our tangent line. And then I'm going to find another point that's on this line to help me with my estimate. Looks to me like maybe it crosses through at 2, 0. So my 2 points that I'm going to use for my estimate are at 2, 0 and -2, 2.5. So, and there's really nothing magical about this. I'm just looking for some points that I can, pull some coordinates off of in order to estimate. Again, keyword here is we're estimating. There's no expectation that you're going to come up with the exact actual value of the derivative using this method. And so we've got, let's see, 2.5 over -4, which is -0.625. And again, we've got no units in here, so we're not going to have any units in our answer. All right. All right, now, the last one. To approximate the value of the derivative at a point when given an equation, we're going to learn how to use the numerical derivative. I mentioned this earlier in the video. It's one of the few things that you're allowed to do on your calculator on the free response section of your AP exam without showing any work. How we handle it is slightly different for different graphing calculators, so we're going to look at the syntax and details before we put it into practice. I'm going to use probably the 3 most common calculators for my students. If you have a calculator other than these, I suggest you look at your owner's manual and, see. All right, so if you have an older TI-83 or TI-84 series, which does not have math type, most of the newer ones have math type in them. The syntax for this model is to type in nderiv, the function that you're taking the derivative of, a comma, the variable, a comma, and then the value where you're finding the derivative, close your parentheses, hit enter, and it'll give you an approximation. So if we're trying to find f prime of 2 for the function f of x equals 5x cubed, we're going to get the nderiv command by typing math, and that's going to pull that out to our main screen. When we hit the 8 key, that's going to pull out the nderiv command, and then we can just type in the function 5x cubed, a comma, the variable that we're differentiating with respect to here, which is x, another comma, and then the value where we're finding it, close that parenthesis, and it gives us our answer. For those of you who use 89 and 92 series calculators, like me, the syntax for this model is to type in d of function comma variable, and then the evaluation bar, and then x equals whatever value you're using. So since we're trying to find the derivative of 5x cubed at x equals 2, we can get the derivative command by typing second and the 8 key. You should see it on your keyboard. And to get the vertical bar, you're going to find that to the left of the number 7 key. Once you've found these, you can type in d of the function, comma, with respect to the variable evaluated at x equals 2 to find your answer. You know, if I pull up my virtual TI-89 here and do this, what I'm going to do is I'm going to hit second and the number 8, that pulls up the d, and then I can type in the function 5x cubed with respect to x, close my parentheses, the vertical bar here next to the 7, and then type in x equals 2, and if I hit enter, it'll give me the value of that derivative at 2. And for those of you who have the TI-83, 84 series with math type, you're going to start the same way that the other people with the TI-83, 84 series calculator started. But when you type math and then the number 8 key, you're actually going to get something that looks like this. It looks exactly like the calculus notation that we want to use. And all you're going to have to do is fill in the dashed boxes. When you fill in this dashed box with an X, it's going to automatically put an X in this dashed box here. You type your function into this box, type the numerical value into this box, hit enter, and it's going to give you the value of your derivative at the point. Okay, if you, like I said, if you don't have one of those graphing calculators, please consult your user manual, the internet, or ask for help in finding the necessary keystrokes. It is a must for your AP exam that you are able to use the numerical derivative. There will be derivatives at points that you cannot find analytically on your exam, or that are exceptionally difficult to find analytically on your exam. All right, example 4, adapted from free response number 2 from the 2017 AP Calculus exam. Customers remove bananas from a display table at a grocery store at a rate modeled by f of t equals 0.8t, sine of t cubed over 100, for 0 is less than or equal to t is less than or equal to 12, where f of t is measured in pounds per hour and t is the number of hours after the store opened. Find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. You know what? I'm running low on time here, so I'm going to call it for this video and just say join me in the next video where we'll do example 4 and example 5 using the numerical derivative to find the derivatives of functions. Okay, sorry about that. I kind of looked at my clock and was like, uh-oh, I don't have enough time to finish. So go ahead and join me next time. Have a great rest of your day, and I'll see you then.